Uh, I work on a number of topics, and when asked to give this keynote, I thought, well, shall I talk about some of my obsessions with the notions of predictability, or shall I talk about some of the work I've been doing recently on mixed criticality? And then I thought, well, I should be able to put these two topics together. So that's what I'm attempting to do, because obviously these things are linked. Now, I do real-time systems research. So most of the time, 95% of the time, what I'm doing is developing ways of ensuring that systems meet their timing requirements, their deadlines. So the term predictability that I'll use quite a bit in this talk is all to do with the predictability in the time domain, predicting the time at which things will complete. So most of the time, as I said, I'm on this bullet point. I've given some sort of system, which is typically a platform plus an application, or more likely a complex platform with heterogeneous processors and various forms of networking and buses, and more than one application to host on that platform, and applications having different software architectures. And they throw that to people like myself working in the real-time area, and they expect us to be able to very efficiently use the resources, they minimize the power, be able to predict the worst-case temporal behavior, even though these platforms are often not fully specified, and make predictions that are 100% absolute. Real-time systems must meet their deadlines. I don't know if any of you were also at Tom's talk on Tuesday. He again was emphasizing this rigidity, that sort of Booleanness, that a system is either correct or incorrect, isn't really an engineering approach. Most other engineering approaches, you're not trying to make 100% predictions, you're trying to be good enough. So what I'd rather like to do is actually myself have some control over the structure of the systems, platform and applications, so that I can fairly easily get to optimal scheduling. I can produce predictions that are tractable, safe, and accurate, and I can admit and actually exploit the fact that predictions are dependent on the criticality of the component, the criticality of the system or subsystems, and so they're not absolute. So I'm taking the opportunity in this keynote to address more the bottom end here. The context